All right, we're continuing with factoring and how to factor different types of things. Remember, factoring is basically doing the opposite of what we did last chapter. Last chapter we did multiplication, now we're going in the reverse direction with factoring. So we're in lesson 10.4 talking about special patterns. So really, again, all of this is the opposite of what we did last chapter. So a lot of this should be familiar. So remember, we have what we call conjugates. When I have a plus b times a minus b, that's going to give me a squared minus b squared. If I have a squared plus b squared, I can't factor that. So anytime you have something squared plus something else squared, you can't factor that. If I have in parentheses a plus b, and the whole thing is being squared, remember this is different than this. This is going to equal this. This is not going to equal anything. So if I have a plus b and then outside the parentheses I have the square, that's going to give me a squared plus 2ab plus b squared. If I have a minus b with the square outside, I'm going to have a squared minus 2ab plus b squared. So the first thing we're going to do is we're going to try to figure out which of these patterns it is. And then based on which of these patterns, I'm going to factor it with one of these over here. So I have x squared minus 49. I have something being squared and something being squared. So it's this pattern right here. So I know I'm going to have a plus b, a minus b. So my a is x squared, so what's being squared? That's x. Here is 49, what's being squared? That's 7. So I'm going to do x plus 7, x minus 7, and that's my answer. So once I figure out what is being squared, here x is being squared, here 7 is being squared. X now is my a, 7 now is my b, so I just do x plus 7, x minus 7 using this pattern right here. So if you have something being squared minus something else being squared, then figure out what is being squared and then use that pattern. Now remember, anytime you factor, your first step should always be to check and see if you can factor out a monomial. That means check if something can be divided by both. So if I have the same letters in both or a number that can be divided by both, start off by pulling that out before you do anything else. So here, notice both of these can be divided by 5. So I'm going to divide both of these by 5. Remember, this doesn't equal 0. 5 divided by 5 equals 1. 125 divided by 5 is 25x squared. So now I divided them both by 5, so 5 is outside my parentheses. Now I have 1 minus 25x squared. Again, that's the same as something squared. 1 is 1 squared, right? And then 25x squared is 5x squared. So, leaving my 5 on the outside, now I have my two parentheses. My a is 1, so that's going to be my first in both of them. My b is 5x, so I'm going to have 1 plus 5x and 1 minus 5x, because I'm using this pattern right here. So first, I factored out, I checked to see if anything can be divided by both. 5 can be divided by both, so I do that first. Then I see that this pattern is a squared minus b squared. I figure out what is squared to equal 1 and what is squared to equal 25x squared. Whatever is squared to equal 1, that's my a. Whatever is squared to equal 25x squared, that's my b. And then I just plug it in and I have my answer. For this one, again, I check first to see if anything can be divided by both. They can both be divided by 4. So I don't have any letters in common, but they can both be divided by 4. So I start off dividing them both by 4. So I put a 4 on the outside and I'm left with 9x to the 6th z squared minus 64 divided by 4, can't think off the top of my head here, is 16 y squared. Okay? Now I check which one is this. Well, obviously this one is this pattern right here again. So I know it's going to be my first one plus my second one, my first one minus my second one. So I'm going to do the two parentheses. Don't forget that 4 on the outside. And then I have to ask myself, this one's a little trickier. I have to say, what squared equals 9x to the 6th z squared? Well, obviously 3 squared equals 9. So I know this is going to be 3. But then anytime you have a variable with an exponent, remember my rules for variables with exponent. For example, if I have x squared, let's do x cubed squared, that's going to be x to the 6th, right? So if I want to figure out what squared is x to the 6th, I'm going to have to divide my exponent by 2. So I'm going to divide each one of these exponents by 2. 6 divided by 2 is 3. 2 divided by 2 is 1. So my first one is 3x cubed z. If I square that, I get 9x to the 6th z squared. Let me show you that. So if I have, I'll do it over here, 3x cubed z, and I square that, 3 squared is 9, 3 times 2 is 6, z squared. Okay? So all I'm doing for my exponents of my variables is dividing each one by 2. Because then when I square that back, it'll give me that. 16 is 4, y squared is y. So my second is 4y. So this is my answer. Remember, the A is what squared equals this. The B is what squared equals this. So 3x cubed z, remember, for the number, what squared equals 9. For the letters, just divide the exponents by 2. That'll give me my A and my B. Now, let's look up here. This time I have 3 different terms. So I know I can't use this or this. So I'm going to use one of these two. So remember, the only difference is it addition or subtraction? This one, the middle term, is addition. So I'm going to end up with a plus b squared. I'm going to end up with something plus something squared. Now here's the big question. What is a and b? Well, remember, first thing I'm going to do is I'm going to rewrite the first and the last as what they are squared. So obviously this is x squared. This is, let me erase this to confuse us. This right here is 5 squared. Then remember, the middle term is 2 times a times b. Okay, so this is true. 2 times a times b does equal 10x. So my a is 5. My a is x. That's my first term. And my b is 5. So I'm just going to do a plus b. So it's x plus 5 squared. So I'm just doing the same thing in reverse. Whatever is the first term, that's my a. Whatever is the last term, that's my b. And I can check to make sure that those times 2 equal the middle term. This one's the same thing, but notice this one is negative. And notice one other thing, these can all be divided by something. So before I do anything, I have to divide them all by what they can be divided by. They can all be divided by 3. So I'm going to divide all 3 of these by 3 and put the 3 on the outside. I'm left with 4x squared minus 12x plus 9. Okay, now I'm going to rewrite my first and my last as what squared equals that. 1 squared equals 9, obviously that's 3. 1 squared equals 4x squared, where 2 squared equals 4x, like that. So this is my a, 2x. This is my b. I can check that. A times b times 2, yes, that equals 12x. So my form, when there's a negative in the middle, is I have to have a negative in the middle, and then the whole thing is squared. So I do my a, 2x, minus my b, 3, squared, and that is my answer. 2x minus 3 squared. And don't forget my 3 out here. I forgot it. So don't forget that 3. That's very important, and it's easy to forget. So I would write that down there first before I forget this. Here's our last one. My first step is always to check if something can be divided by all of them. This one doesn't even have a number, so I know it's not a number. Is there any letters that are the same in all of them? There's an x here and an x here, but no x here. There's a y here or y here, but no y here. There's z's here and here, but not here. There's nothing that's in all 3 of them, so I can't divide anything by all 3 of them. There's 3 terms, and the second one is negative, so I know I'm using this one. So again, I know my answer is going to be whatever squared equals this is going to be my a, and whatever squared equals this is going to be my b, and it's going to be subtracting. So remember, if I have exponents, I just divide by 2. So 6 divided by 2 is 3, so it's x cubed. 4 divided by 2 is 2, so it's y squared. That's my a. 1 squared equals 16, that's 4. 1 squared equals z. That's obviously z. I could double check it by doing 2 times this should equal that. And that does. So this right here is my answer. And don't forget the squared on the outside. So that is lesson 10.4, the special patterns. Again, this is just a reverse of what we're doing before. Just to review really quickly, your first step for these is always going to be to figure out which of these 4 is happening. And then rewrite, if it's just 2, rewrite each one as something squared. And if it's 3, write the first and the last as something squared. And that will be your A and your B in the pattern.